Welcome to lesson 29. We are now starting into derivatives. So what's your goal by the end of the day? I want you to be able to make connections with the previous investigations and the rules that we present today. And I want you to be able to take those particular rules and I want you to apply them. So what are we looking at? A derivative. Okay, and here's a definition. A derivative is a limit that arises when finding the slope of a tangent line. And I said in the calculus portion of this course, that's all we're doing. We are finding slopes of tangent lines. Now, the derivative can be presented or interpreted in two different ways. The first one's the expression for the slope of a tangent line, and that's what we're looking at in Unit 3. Okay, so Unit 3 is we're just finding an expression for the slope of the line. And in Unit 4, we're going to look at instantaneous rate of change. We're going to apply it to real-world situations. So the derivative from first principles would mean the following process that we've been working on. So you already know that the slope of any tangent line can be determined using limits. So the limit as x approaches the point in question for f of x minus f of a divided by x minus a. Or we know it as the limit as h approaches 0 for the function f of x plus h minus f of x divided by value h. Okay. There's going to be one question on the test. So one question. And it's going to read as follows. Determine the derivative of the function from first principles. From first principles. Okay, and first principles is using one of these two processes. All right, so you are going to have to come back. You do have to show it to me on the test. You do have to show it to me on the exam. But now we're going to look at some patterning that occurs and some shortcuts. We're going to talk about that. So graphically, what I have here is a quadratic function, or sorry, a quartic function. And what I want to do is I want to take the xy values, and what I want to do is I want to plot the slope of the tangent from the quartic onto the axis to the right here. And we're going to be plotting the value of slope on the y-axis, and we're still maintaining x values as well. So you're asking, how are we going to determine the slope of the tangent line? Well, let's pick off the slopes that are easiest. And the easiest slope to find on this quartic is where slope is 0. And that occurs when the tangent is at a max or a min. So on all three of these locations, the slope is 0. So the value of slope is going to be my y-axis in the second graph. So that means at -2, it's going to cross the x-axis because the slope is 0. At 0, it's going to cross the x-axis because the value of slope is 0. And at +2, it's going to cross the x-axis because the slope is 0. Now, let's talk about the value of slope. At those points, if I break the quartic into regions, I'm going to break them into what I'll call region 1. I'm going to break it into region 2. I'm going to break it into region 3 and 4. Let's just take a look at the slope, or the value of the slope here. So I need to give myself a line that I can use here. So where's my line function? Here we are. So here we go. Here's my tangent line. So in region number 1, what type of slope do we have in quadrant 1? So the tangent line would look like that, or I can move it up a little bit, and it's going to be up here, and so on and so forth. Regardless, every time the slope in region 1, the slope is going to be a negative slope. So slope is going to be less than 0, not equal to. All right, because the slope of that tangent line is always negative. All right, when we move into region number 2, you see that the tangent line would switch after it reaches 0. And in region 2, we find that the slope is going to be greater than 0. It's going to be a positive slope. All right. Similarly, following that same pattern into region 3, the slope then of the tangent, remember this line that I'm drawing represents a tangent line, just going to touch the curve in one location. It now is negative again, so the slope's going to be less than 0. And over here in quadrant or section 4, the slope goes back to being positive, so it'd be greater than 0. So what does that tell me? Well, in section 1, slope is less than 0. So that means that for values less than -2, it has to be below the x-axis because it's going to be a negative value. So from -2 to the left is going to be negative, because remember, slope is our y-axis. It's the value of slope. In section 2, slope is always positive. However, if I can get my line segment back here for a second, what's happening to the slope? As it comes out of being 0, it's a very, very low slope. And then halfway through, the slope gets very, very steep. And what happens back here? It approaches 0 again. So it goes from a slope of 0, so a slope of 0 right here. It then gets steeper, and then all of a sudden it starts to decrease because it has to get back to a slope of 0. So in that region, I don't know what the actual slope was, I just know it existed in section 2 above the x-axis because it had a positive slope. I know in section 3, the slope was negative the whole time. It was less than 0. So that means that it's going to be below the x-axis because it does, again, the slope goes from, starts at 0, it'll get really, really steep in this section, and then it goes back to 0. And they were talking about these are our y values. So there's 0, there's the really steep part recorded, and back to 0. We know that we already talked about section 1, less than -2, the slope has to be negative. So based on my curve, my graph that I have in my segment here, it's never going to cross the x-axis, so I got to draw an arrow and sketch it such that it's never going to touch the x-axis. Similarly, in quadrant 4, it's never going to cross the x-axis, so I have to draw it like that. So what do we notice here? We notice that we had a quartic, a degree 4 function, or degree 4 polynomial, and when we sketched its slope, or gave a rough sketch of the derivative, sketch of slope of tangent, we find that the resulting general shape here is a degree 3 polynomial. So the degree, in this case, seemed to drop down 1. So I went from degree 4 to degree 3. So we'll do one more investigation to see if that trend continues. So over here, I identify where is the slope. So here's a cubic. So here's a cubic function or a degree 3 function. So degree 3. So what happens with this one? I'm going to find where's slope 0. Slope is 0 there. Slope is 0 there. So at the values, it looks like 1 and -1. 1 and -1. Slope is 0. So again, y-axis on my new graph is going to be a slope, still the x values. So what does that mean? If I get my line, construct another line again. When does it change? So here, where I have my line, we have a positive slope, and then when it goes past the point where the slope was 0, the tangent line would have to be drawn the other direction. So we have, once again, created regions at those max mins. So slope is greater than 0 in section or sector 1. In sector 2, the slope is negative, so it's going to be below the x-axis. And in sector 3, again, it's going to be greater than 0, because if I move that tangent line over here, it's a positive slope again, even though I'm having trouble drawing it. There we go. All right, so what does that mean? Well, that means in between where the slopes were 0, our slope is going to be less than 1. So that means over here, we are going to have some type of curve in here to represent a slope less than 1. What's happening on the outsides? Well, here, slope is positive, and in section 3, it's positive. Never ever crosses the x-axis again, so it must continue. And I know I've cheated on the shape a little bit there, but the result is now we have a degree 2 polynomial. So when we find the slope and plot the slopes, okay, we are finding that the degree is 1 less. The graph that's produced is 1 degree less than its original graph. All right. So talk about differentiable functions here just for a second, because that's where we're heading with this. I'm going to talk about the notation, and I'm going to talk, actually, I'll wait to the next video to go through and talk about this particular slide, because I don't want to rush through it.